Hello and welcome to this tutorial, and in this video I'll be trying to take you through how you can manually draft a survey plan using Revit. Now in most cases the survey plan could be available to you in a digital format that is done in AutoCAD, and you can easily copy it to your Revit and start your project. But when you are not being given that kind of a file, a soft copy, from an AutoCAD copy that you can easily take to your Revit, what do you do? So you have to manually draft it, and in this video I'm going to be taking you through how you can easily draw those lines using the bearing, that is the angle, and the dimension that are available. So in this tutorial I'll be making use of this particular survey plan. It's a very simple survey plan that is just made up of 4 sides. So and I'm going to be looking at the beacons, the property line, the beacons now for the survey plan, and I'm going to be making note of the angles and their distances. So I'm going to start by drawing this particular survey plan, referencing the beacon that has that or the distance line that has that angle that is just under 90 degrees, because that is where the starting point is. And you should take note of the fact that when you are drawing your survey plan, you should be drawing in a clockwise direction. So I'm going to draw that particular line, which is the first line of this survey plan, and I'm going to impute the dimension, and then I'm going to check the angle. When you are drawing the line, you may not need to worry about the angle, but you can easily now go to the annotator dimension and then use the angle to dimension that angle, and then change it to the angle that is exactly on the survey plan. So I'm going to change that to the angle that is on this survey plan here, and it will automatically adjust it to become the exact. Now where it may get tricky will be in the second line. So I'm going to try to draw the second line, which is going to be at an angle that is just less than 180 degrees. It's going to be on the second quadrant, working with an anti-clockwise, a clockwise direction here. Now the angle on that line, I'm going to take it out from 180 degrees. So after I've drawn the line and imputed my dimension, I'm going to subtract the angle that is there, the bearing on this line, from 180 degrees, and whatever is left I'm going to use that to correct the angle. So I'm going to check the angle here, which is 172 degrees 3 minutes. So I'm going to subtract that from 180 degrees, and whatever is left I'm going to use that to cross-reference to make sure that the bearing is correct. So I'm going to click on the line and then change that angle to the result. So that is it. And I'm going to go to the third line, the third side of this survey plan, and I'm going to, now the bearing of this line will be in the third quadrant, that is will be in the 270 degrees end. So I'm going to take the angle that is on that line, the bearing of the line, I'm going to take it out from 270 degrees and then use that to orient this particular angle. Now the reason you do this is because Revit most of the time only measures angle within 90 degrees, and sometimes you may not be able to measure an angle that is over 90 degrees. So in order to prevent errors, you have to subtract this. So I'm going to subtract that and then impute the remaining. It's just below, just 5.87, and I'm going to adjust that so it become automatically and then here I can just close my draft. Now you don't need to be worrying about maybe some error that may come up here, because there could be an error margin here when you are closing, maybe due to some the bearing and some other errors that were there. But the error when you close this particular survey plan, the error should not be so large that it is compromising. For me, normally if it's the error is within 50 millimeter to 100 millimeter, I think that should be okay, because definitely there will be an error, especially when you are closing. So you can see here this is 22,843, but on the survey plan it is 2290. That is a difference of about 57 millimeter. So that is very, very, very low. So I think it's to an extent acceptable in terms of the error margin, but the other side are the same as what is obtainable on the survey plan. Now the major reason for this is if you really do not have just like I said, and if you really do not have the digital copy, that is the AutoCAD copy of the survey plan, and so you need to do this to be able to bring it up before you now work with your site. But if you already have the AutoCAD, the DWG file, you don't need to do this, just import it, and you are ready to go. But with this, if you don't have that particular format, you can easily draft it here. It will not be any issue at all. So that is that for that. And yeah, so in another thing too, in other survey plan that may be very complex, you may need to apply the same approach. You just need to start from the angle that is below 90 degrees and work your way to the line that has a bearing of just below 180, and you will see the progression. You walk clockwise, not anti-clockwise. So it applies to whether the survey plan has many sides or not. It's the same approach you need to use in Revit. So I'm going to change the line to the property line style. Yeah, that is that for that. So if you were wondering on how you can easily draft your survey plan using Revit, so that is how it is. Now this is the manual type. Now there is the other type that you can draft your survey plan using those bearings. I'll be showing that in another tutorial. Thanks for watching and goodbye. So the second part in drafting a survey plan is using the property line tool that you find in other massing and site. So when you come to this very icon here, this very menu, and you come to this tool, you can easily use this property line to plot your survey plan. This was done with detail line, but if we want to use this property line, we have to make sure that we have the various bearings for the different side of this particular site. So if I click on this property line, I'm going to be shown two different option here. There is the create by entering distances and bearing, which I will be using, and there is the create by sketching. So this sketching is more like similar to what we did using the detail, the annotative tools. So I'm going to just go straight to this part and click on it. If you click on it, you'll be shown a different set of parameters here, and this is where you are supposed to enter the distances of the line and the angles, that is the bearing. So I'm going to start from this particular end here, this particular point where the angle is just below 90 degrees, and I'm going to work my way. But in this particular end here, one thing you should note here is that the angle that appears on your survey, you won't be able to use it directly. So I'm going to show you what I mean. Let me first of all bring out plot the first line here. The first line had a distance of 37 meter 460. That is 37,460 millimeters, and it's oriented towards the north because this is the northern end of this particular survey plan. It's oriented towards the north and it's going towards the right hand side. The line is going towards the right hand side, and the angle is 78.23 degrees or 78 degrees and 23 minutes. So the north and south orientation is I will put it on north because the line is at the top and it's going upward. So it's not coming downward. If it's coming downward, then I'll be saying south, but it's located at the upper quadrant on the northern end. So I'm going to change this angle to 78 degrees and 23 minutes, and it's oriented towards the eastern side, that is the right. So if I OK this line, this is what is, you can see the line is automatically the same as what I have already on my side, but this is totally gotten from just plotting the direction, that is the bearing and the distance. So if I place it here, it's going to be exactly the same distance and it's going to towards the same direction. But I want to plot the whole site, as in I don't just want to plot a single line. So I'm going to click on it and then edit the table, and here I'm going to insert the other various line. Now here is where the issue will come from. Now this other particular line here, this one is oriented towards the south. So on the survey plan, you are not going to be using whatever they had there, because just like I told you earlier on this tutorial, when I was drafting using the ordinary line, it's working in a clockwise direction in terms of the angle, the bearing that they use in this survey plan. But since this line is coming downward, I'm going to make use of the southern pole, and I'm going to just take a dimension. Let me show you what I mean here. I'm just going to take a dimension from the southern pole to my line that is just coming downward towards the right hand side. So what I'm going to do here is to note this angle. And this angle is gotten from the distance between the line, that is the survey line now, and the southern pole. It's just like you have it on the survey. If I were to do my quadrant, I will have a line. It's more like the 180 degrees minus 172. So whatever is left there is what you are going to be using, since the line is oriented towards the southern end. It's quite complex, but if you understand the approach, you can easily use this particular method to plot your survey without really drawing. All you just need to do is to impute the angles and impute the length, and Revit will automatically plot it for you. And I'm going to insert the other line, this particular line now, and I'm going to use that angle. Now the distance there is 26,710, and it's going to be coming downward. That is towards the south and towards the right hand side. So it's still going towards the right, it's not going towards the left, so I'm going to leave it at the east. The east is the right, west is left, down is south, up is north. So when the line is going up, you are going to be using the north on this particular drafting here. So I'm going to leave it at this point, and then I'm going to change the angle to 7 degrees and 98. Now Revit is going to automatically adjust this angle to become 8 degrees 38 minutes, because of you can't have a 98 minutes. So you can see Revit has adjusted that because it exceeded that 60 mark. The minutes and the seconds will always end at 60. It will not get to 100, except it's only the angle that will get to 90 degrees. It gets to 90, then it automatically changes. So this is that 7 degrees 98 7.98 degrees is going to be 8 degrees 38 minutes, and so that is that. And then we insert the other line, the other sorry, we'll remove that because the line will be we'll move it down. The third line is 37 970 37, and it's coming southward too. We're talking of this particular line that flows from this point here, so it's coming downward, so it's at the southern end, and it's going towards the left, so it's going to be west, and the angle is 84 degrees 13 minutes. So I'm going to okay it here and just show you what I've done here. Look at the progress of our survey. You can see there's only one line remaining. You can see it's totally it's totally looking like what I plotted earlier. So this particular angle here is gotten from since it's on the southern orientation, so you just take the angular dimension from here. So you can easily still get that from the survey map. All you just need to do is to remove your 180 degrees, so whatever is going to be left here, because we are making use of this particular point since the line is on the southern end, so we'll measure from here to here, and we'll get that angle which you can use for the bearing. Normally, in order to quickly use this particular tool, the surveyor, we have to provide these particular angles and the orientation, so that it will be easier. But if you are going to draft it on your own, then you have to ensure you get these particular dimensions to be able to carry out this particular draft. So all I just need to do here is to still go to this part and I did the table, and I will just ask Revit to add a line to close it. The reason why we do this to ensure that my plotting is I don't have any issue, and Revit will find a way to calculate whatever it is to close this particular point here. So I'm going to just OK it, and Revit will close it for me. Now you can see on the table, look at the dimension here, 22,878.2, and on this part is just 2290. So it's a little off in terms of the dimension, but it's just like I told you earlier, there will be an error margin. So long as the error margin is not very large, it's not more than, at least advisably, it shouldn't be more than maybe 50 to 100 millimeters. and that will still be at least okay. So you can see this how you can easily draft your survey plan, making use of the angles provided by the surveyor and the distances. So it's either you can draft it manually using your detail line, just like it's found here. If I come here and I say create by sketching, I can easily do that, just drawing my line, and making reference to whatever angle and distances the surveyor provided. So, but this is done using the bearing, and it's a very close sketch, and it's quite accurate based on what the surveyor provided. So that is how you can plot your survey, and yeah, that is that for the tutorial for now. Thanks for watching, and